Okay, so at this point we've got everything skeletoned in and we have our 4 icons being drawn out to the screen. So it's time to get the sequence going and seeing these little guys pulse, just that, we know that the sequence is working. And really the heart of that got kicked off all the way back when we called upon append sequence and we sent it 3. So Logan, I guess what we can do is let's start at append sequence and start working there. So when we tell it append sequence, add 3 to it, what happens inside?
Well, let's take a look at that. Let's go, we're in the game class, so let's go all the way back up to the top where we have the append sequence method, and let's code the implementation for append sequence, which is actually very simple.
Very sequency.
Exactly. We're going to have a for loop. Now, for loop is going to continue to loop for whatever count we've given it. So for I is less than count. And inside of this loop, all we're going to do is tell the sequence to add an element, and we want to add some bytes. So we're going to take our random, generate a random number, and then we need to generate a random number that's within range of the directions that we have. So we're going to give it buttons.length. Length should be 4 because we've made 4 buttons at this point, but of course next is going to be non-inclusive on the upper range. So next for 4 is going to give us 0, 1, 2, and 3, which are all valid indices for the buttons array, which
Correct.
works out nicely. So if we end this off, we're going to need to cast because next is returning an int. The sequence is of type byte. So we'll cast this to byte before storing it inside the sequence.
Okay.
So we can build, make sure that that's working, and everything looks good there.
All right, so now that we have the sequence being built, if you will, or at least the start of it, let's go ahead and pulse is right below you. Let's go ahead and put the pulse in, which is really simple. It's just basically saying, a particular button, whichever button index we send in, let's pulse and send it a pulse duration.
So let's look at our buttons array, and let's take the button that's given by that index. So button for button index dot pulse, and pulse is going to be looking for a duration. So let's feed it the pulse duration field that we had defined above in the game class.
Perfect. All right, so now that we're calling upon button, let's go ahead and put some functionality over in the button class. So let's go ahead and visit the pulse method over there.
All right, beginning with pulse. Let's see, pulse needs to do 2 things. It needs to turn on the color so that it changes to white, and it needs to set up the time remaining so that that can start counting down. So to look at the time remaining, we need to set that equal to the given duration.
Okay.
And then we need to change the color to white. So color equals color dot white, which will represent full brightness, since before this we were gray in color.
Okay, so now that it has been activated, if you will, now let's go ahead and code in the update because we need to make sure that counts down.
Right. So inside of update, the first thing we need to do is a check to see if there's any time remaining. So we'll say that if this dot time remaining is greater than 0, then we need to count down, and then after we count down, we need to do a check and see if we've run out and need to basically turn the pulse off. So we'll say this dot time remaining is decremented by the given game time dot elapsed game time dot total seconds. And then after we decrement that, we need to do a check and see if this decrementing of time has caused us to go below 0. So we could say if this dot time remaining is less than or equal to 0, then we have run out of time and this pulse has expired and needs to go dark again. So we do that by saying this dot color is equal to gray.
Excellent. Simple enough.
So let me build, make sure that there's no errors, and everything's looking good.
Okay, so now that we've got some stuff set up over here in button, so that's ready to go, at least right now, I guess we can go ahead and turn our attention back over to game, and let's jump down to update because that's really the beating heart of this whole sequence right here, because obviously everything needs to constantly be, running, and that's going to happen in update.
Right, as time goes by, we need to take a look at, maybe go through the interval.
A bunch of things. What state are we in, the interval, etc. Yeah, all of that good stuff.
Right. So beginning in update, the first thing we want to do is to go through all of our buttons and tell them to update. That way, if any button is trying to count down a pulse, it will be given an amount of time to count down by. So we'll do a for loop to go through all of our buttons. And we'll do that by buttons.length. And then we'll take each button by index, so I.update, and we'll feed it the given game time. Alright, the next thing we need to look at is our game state. So we need to go ahead and set up our switch for game state so that inside of that we can look at output for doing this sequence output. So let's make our switch for game state, and we'll set up some cases. We'll have a case for input, and oh, okay, I see. That's actually game state dot input, and put down our break. And we have a case for game state dot output, and its break, and a case for game state dot succeed, and I'm going to group that with fail as well. So game state dot fail will have both of these operate under the same block. All right. Now we can turn our attention to output. Since this is how the game begins, we begin in the output state and we display the sequence. So inside of output, what needs to happen is we need to look at our time interval. Make sure that we continuously count down time, and if we run out of time, then we need to display one of the elements of the sequence by pulsing a button. So inside of output, the first thing we'll do is take time remaining and decrement that by the amount of time that has passed, which is game time dot elapsed game time dot total seconds. Now, if that has reached 0, then we need to go on and look at issuing a pulse. So we'll say if the time remaining is that oh, I see what that is. Really, the way I had been addressing this is this dot time remaining. If this dot time remaining is less than or equal to 0, then we need to issue a pulse. So we'll call upon the pulse method, and we'll set the pulse for whatever. Now let's see, pulse of course is going to take in a button index. Which button are we pulsing? Well, that's dependent on where we're at in the sequence. So what we need to do, or which direction is relevant for where we are in the sequence. So pulse actually takes in the sequence at the given sequence index. And this is why we need to remember sequence index as a field, as this value has to be remembered as the game continues to operate.
Because now you're going to step to the next sequence index.
Right, so if this is going to start at 0, sequence sub 0 is going to be a direction, 0, 1, 2, or 3, representing one of the directions, being a valid direction to send to pulse. Now, after we've done this, we need to advance the sequence. So we'll take sequence index and increment that. Now, we need to do a check, though, and make sure that, since we've incremented this, have we gone past the end of the sequence? Because if we have, then we're done displaying things. So we'll do another check and say if the sequence index is greater than or equal to sequence.count, and really, I mean, the greater than isn't generally going to happen. It'll just be equal to, but we'll leave it there as a safety measure in case we ever come up with a case where we could jump in the sequence. So if we have gone past the end of the sequence, that means we have displayed the very last element here. So what we need to do is to clear out the player sequence. And the reason we're going to do this is if this had been a subsequent round, we need to make sure that there's nothing left in the player sequence before we start allowing the player to put in input. So we'll tell the player sequence to clear, and then we'll take the game state, and we'll set that to input. And I guess really for, let's see, player sequence clear, input, and that should be, I think, all we need. Let's see, after we do the check. Oh yeah, okay, one last thing that we need to do is if time remaining was less than 0, we do whatever is necessary, and then as we exit out of that, we need to make sure we reset the time remaining so that this will continue to count down and hit again in another interval. So that would be this dot time remaining reset to this dot time interval. And that should take care of output. Okay. So we can build, and there's no errors, and I'm not seeing anything else, so we could try running and see what happens. So up, right, up, the end.
Hey, very good.
That actually worked very well. And even showed that the append sequence for 3 numbers was actually working.
Just run it again before you change 3, make sure it's something different.
All right, so we've got left, right, right.
Very nice.
We could have down, up, up. Or we could change this to be maybe twice as long. Let's set that to start out at 6. So 1, 2, 3, 4, 5, 6.
Excellent.
And let me set that back to 3 because that's the way the game is
Sure.
supposed to start, is at 3.
Okay, so Logan, let's keep this broke up into smaller chunk sizes for all of our students. So at this point, we now have the sequence being generated, and we'll just wrap this section of the video up, and in the next one, we'll go ahead and start implementing the input from the player and comparing it against the actual sequence, their sequence against the stored sequence. And then if they match, we simply grow the sequence by 1. So that will wrap up this part of this proof of concept application. Thanks.